Hi, I'm Andrea Clarkson, who's president of the Engineering Design Club at Kenyatta College, and I'm here to talk to you about some introduction into the Arduino with a little intro into programming in general and Arduino programming. So let's get started. Alright, so really what is an Arduino? Well, it's a tiny little computer that doesn't have any instructions on it. So all of the programming that is really on an Arduino, the user is going to upload into it to tell it really what to do. It's kind of essentially the DIY, the do-it-yourself kind of computer. And actually, it does have some instructions. The only instructions really that it has on it is the instructions for the compiler. And what the compiler does is it interprets the code given to it and it turns it into machine code. Because electronics, they can't read words that we program. So it has to be turned into kind of ones and zeros. 0, 1, 1, 0. It kind of turns it into ones and zeros so it can understand and it can run. And that's all the compiler does. But it has the ability to turn it into machine code, but it hasn't been given instructions to tell it what to do, really. So that's kind of our job. So in this, you're going to write your own code. The user has to write their own code, and they do it in a thing called an IDE. And what an IDE is the environment at which you write all your code, and you're going to compile it and upload it. And so this whole thing, it's a program that is used. This whole thing right here is the IDE. So that's what that is. This little button at the top, right here, this check mark, that check mark compiles it. So in your IDE on your computer, this is all in your computer, the IDE is a program. This check mark is going to compile it on your computer that you're going to write the code in your program. And so this compiler basically will check to see whether or not your code is good. It checks whether your code is good, whether your code is good. And this arrow mark right here, I'm gonna put this down here. That is where you upload the code. This is the upload button, and that's to upload code onto the Arduino. And that's all done via a USB connection. So you would connect on USB into your laptop or computer or whatever. And on the other side, you'll connect the other end to the USB port that's on the Arduino. So that's how you upload code. Getting started with the code. If you're familiar with C++ or C, it is very similar to it. So there are some things that are different. For instance, there's no main function. That's kind of a big difference. There is kind of a main function, but and you'll see that in a sec. But there's no function that's called main that is the main thing that executes. So instead, there are functions that execute once, and that's kind of where you declare things or state your functions. And there are also a function that continuously loops forever, and that's a void loop function, which we're going to talk about right now. If you're not familiar with C or C++, then don't worry about this. Two types of functions, really, at the beginning. We have a void setup function, and you notice right here, this only executes one time. So the stuff that's in these brackets right here will only execute once, okay? And so this declaration, this is where someone declared something. They initialized this function. This only gets done once. It only executes once. Whereas, let me change colors for a sec. Let me do this in blue. Whereas the void loop will loop the code to run over and over again. So this is actually a forever loop right here. It's going to run forever. And all the stuff that's in here, so between these two brackets after the void loop, that's going to run on forever. And it's going to keep running until, whenever. I'm not entirely % sure if you can put a condition in these brackets. I don't know if it's like a for loop or not. So you may be able to put a condition in there, but I don't think so. I don't think that that's allowed in the Arduino code, but I may be wrong. So just keep that in mind, that if that's what you're looking for, I'm not entirely sure about that. So it's time to talk about variables. Variables are actually, it's a common concept in all programming languages. But we're going to talk about specifically in C, C++, and Arduino code. So variables are exactly like math, where they can be different numbers or decimal numbers, or even in some cases in programming. Maybe not in math, but in programming you can also call them characters. But it's important to recognize that unlike math, variables, they're not always called X, Y, or Z. Usually when they're named, variables are named, they have to do with their purpose. So if I wanted to, let's say hypothetically, create a variable that had to do with the number of lights in a room, like how many lights are in this room, and I'm going to call that a variable, I'll probably call it the variable of the amount of lights in a room, number of lights, and that is the name of my variable. And you notice that when I change to a new word, it's all combined into, there's no spaces in between my words. They're actually just signifying that I'm using, there are different words in there. Notice I have capital letters, so let me actually underline this in a different color. This O and this L, they're actually capital letters. So it's important to recognize that this is all one continuous statement, but in order to differentiate between words, I capitalize them. That's pretty common in programming when you're naming variables. It's useful to use these sort of techniques because not only will it be easier to read for you later, but also when you transfer the code to someone else or you ask someone else to read it, it makes it a lot more legible and user-friendly. Another method of naming variables has to do with underscores. So I could have also, it's very common and accepted if I write the variable like this. That's pretty common as well. And so yeah, these are the two really commonly used methods of naming variables when you have more than one word. And a lot of variables are going to have more than one word. So in front of the name, whenever I declare a variable, I need to give it a kind of type. So in this case, these types sends a number of lights. I can't have like a half a light or 0.3 of a light. I'm going to call those an integer. Okay, so that's all it is, an integer. And at the end of the declaration of the statement, I'm just going to put a semicolon. So most of the lines in C, C++, and Arduino code, they end in a semicolon. Not all statements, so there's some things that are exceptions. They don't always have a semicolon. But a lot of statements, maybe most statements, have a semicolon after them. And that's all I'm doing here, is I'm initializing these variables called number of lights. All right. So these are the different types of variables, the types of variables that you can have. I'm kind of going to do them in groups. So here are kind of our integer variables, and they represent whole numbers. So just like in math, you can have whole numbers, so numbers that do not have a fraction or a decimal that's associated with them. They're just they're 1, 2, 3, 4, nothing in between. Those are the integer types, and they will only accept kind of things that, well, they'll accept more, but they will hold integer values. So if you look over here at the range, here's our ranges. They hold a range of values. So if you want a short integer can only hold values from 0 to 65535, and that's associated with how much memory that you have to them. So if the more memory, the more different types of numbers and the larger numbers that you can hold. The less memory that you allot, the less numbers that you can potentially hold, because it can only hold so much space. If you notice integer and long int, these are the same. That's because integer and long int have integer's default value is long int. So default is long int. So I guess in a sense there's only short, and in reality, in terms of memory, there's only a short integer and a long integer, but we usually abbreviate long int to be just int, so that's abbreviated. We have another type that we're not as familiar with. It's called char, and that stands for a character. And it's a single character, so that's really important. It's not a bunch of characters, but just a single character. So, and it can hold values, not only just numbers, because it can assign numbers too, but also it can do characters like the letter G or the letter Y or an apostrophe or star or pound, a lot of things on your keyboard, and so you can kind of hold them as a char value if you have a different type of value that's not a number. Alright, so that's what the char is for. We have another one called Boolean, and this is a Boolean value. That has to do with true or false. So it can only hold kind of two states, a true or a false state. Alright? Also, lastly that I'm going to talk about are the float double and long double. So these have to do with decimal numbers. So instead of integers, if you want to have some sort of decimal that's involved, there are many different programs that involve partial numbers. That's what these are for. So the double, the float type, the double type, and the long double type. And notice that I guess these also have a similar precision and default. So there's less memory allotted to a float than this. These have more memory, so it's more. You can have a larger range of values, so more memory. If I can spell it, larger range. All right. Libraries are things that we're going to get onto later on, but it's kind of an important topic to know that's there. So in the Arduino, we're going to have different types of hardware. We're going to include hardware that's not a part of the kind of the Arduino set. And we're going to probably buy, like, for instance, motor shields, different types of sensors, and other things that have their own libraries. And so one of the ways that we kind of can effectively use the hardware that we buy, these are usually like prepackaged kind of, these are kind of nice designed hardware already, pre-designed hardware that we buy, like a sensor or a motor shield or something. In order to use those things effectively, you can use their library. So a lot of this hardware have libraries that are associated with them, so you can use them really easily. Libraries are just compilations of functions that you can call upon, and so they have a bunch of a bunch of functions that have to specifically do with that hardware. And so it makes your life as a programmer easier. You have to download those libraries, and which we'll talk about later when we start using more things. But you have to download them and kind of read up about how some of these functions work. But after that, you can use them just fine, and it's highly encouraged to use them too, because people design the hardware with the idea that there's going to be, especially for things like Arduino, they design it for these libraries to make the libraries easier for you to use their products. So we're going to talk more about that later. So called functions are functions that you just bring up or you call upon. That's why they're called functions. These are some ones that we're going to use in the beginning programs that have to do with the Arduino. So these are already in there. You don't need to download a library or anything. So let's talk about the digital write. Digital write is a function that kind of defines its pin, and here's the pin right here. We're talking about pin 13. And notice that it's inside these parentheses. We have parentheses here. So the first number in digital write basically defines that what pin you want to use on the Arduino. The Arduino has pin numbers on the digital side, and you're basically assigning a pin to that. And then the second number, notice there's a comma right here. The second is not a number. It's basically a state or a condition that you want the pin to be. So a high is means that you want to apply some sort of voltage. Apply voltage to the pin. To pin. A low is to not apply voltage, or apply a voltage that's so small, or not apply voltage, or just not doing it. So the other type of function that we have going on here in this is the delay function. And if you notice, the delay function, I'm going to is it basically holds the program. So it tells it to just keep doing what you're doing. It's just going to wait there. And so that's what the delay does. Just keep going. I'm just going to wait for a sec. And so notice the units, and important to realize that the units are in milliseconds. So this 1,000 milliseconds, well, that's equal to 1 second. And so it's important to realize that the delay works in milliseconds. Logic. So when we're going over programming, it's kind of impossible to not talk about logic. One of the first things to talk about is that logic is completely based off of whether or not a statement is true or false. So it's a statement that is true or false. So it's important to realize that you need to have some sort of comparison or some sort of statement to make something true or false. So this idea can kind of be utilized to make a tree. So this makes a decision tree, gives the program a fork in the road or something like that. But I like to think of it as a tree. So kind of one way that you can utilize these true or false ideas is with an if statement. So basically an if statement, it says, if this condition is true, then run this code. All right? So it checks whether or not a condition is true. If it is true, then it'll do the code. If it's not true, then it just skips over that code. So in my example right here, I start off with this if statement. Let's say my LED state is a variable, okay? This is a variable. And I'm going to say, well, if this variable, called LED state, if it's equal to, so this is a double equal sign, it's a conditional equal sign. If it's check whether or not LED state is equal to low, all right? And that's what this is the stuff, this is called what's inside these parentheses. That's the conditional parentheses. Everything inside of it is the condition. All right. These brackets right here signify everything that's in between the brackets. So everything that's right here. You notice that looks a little bit messy, but everything that's in between the brackets, like when you're reading, because code reads from left to right, is going to execute when this condition is true. So executes when condition is true. All right. If it doesn't, it's going to move on. All right. And let's talk about the else statement. So I'm going to do this in a different color. We have another thing called an else statement. So what an else statement does is the code, there's always going to be before an else statement, there's going to be if statements before an else statement. So if statements will be before an else statement. And basically what it does is that if all else fails, so you have a bunch of if statements before it, an else statement has to be the very last option. So you can't go if, else, if. Okay, it's gonna, all the ifs go first, then the else is at the very end. And basically what it says is kind of in the name, if all else fails, then do the else statement. You know, so if all your conditions, if all your if statements before it draw in false, so you didn't go to any of them, then it's going to automatically go into the else statement. So in this code, my if statement, if my if statement before it failed, like let's say my LED state was at a high instead of a low, then it will go through this else statement and it will execute this else statement. And the stuff in between the brackets will then execute. And so then we're going to turn this high condition. It starts off high because if it's not low, it has to be high, right? The LED state. The if statement failed. Only goes when if fails. And I'm talking about the if statement, right? So this only goes when the if statement fails. And so the only way that it can fail is if this was not true. If LED state is equal to low, if that is not true, then it must be high. And so this is basically is going to change the LED state to a low state. Okay, so it's going to go through the code between here. When LED state is a high, it's going to change it to a low. So what this overall program is doing, if you haven't caught on, is it's going to blink blink back and forth. So it's going to turn the LED on and off. This will forever turn LED on and off. I forgot that there needs to be a loop here, so imagine there's a void loop, because this is inside probably a void loop. And then here's my curly brackets, and here's my end curly brackets. So imagine it's going to keep looping over and over and over again, then it'll turn this LED on and off. So it's a good, I took this from the blinking program that's on there, on the Arduino website. If statements, and now let's talk about the kind of conditions that are inside our if statement. So if you remember from the last slide, we have if some sort of condition is true, and the condition goes in between those parentheses, then you would execute that if statement, the meat of that if statement. Well, to break it down, a condition kind of consists of two parts. The condition consists of some sort of thing, and I'm going to call this thing 1. And you're going to have some sort of operator right here, conditional operator. And then it's going to compare it to thing 2. And that's kind of what makes up or comprises a condition. So over here we have some operators. Kind of here's our operators over here. And let's start with the equal to. So you notice that this is basically going to say that thing 1, if you want to say thing 1 is equal to thing 2, and that's what your condition that you're going to check. That's what this one does right here. And notice that this is a double equal sign. It's not a single equal sign, so it's double equal sign. It's not a single equal sign. It's for basically differentiating between the condition or the conditional operator equal to and just a regular statement that's saying that this is now equal to this. Next we have a exclamation mark not. So the next statement is not equal to, and this exclamation mark basically means not. Alright, so you can read it out just like you would in English. Thing 1 is not equal to thing 2, and that's the condition that you're checking. Alright, these ones are kind of self-explanatory. I think that most people can understand that these are less than equal to, greater than equal to, less than or equal to, or less than and greater than. So basically an example of this would be thing 1 is greater than thing 2, and that's the condition that you're going to be checking in the if statement. Alright? To make things a little bit more complicated, inside your if statement you don't need just one condition, you can have multiple conditions. And a way that we can kind of compare these two conditions are using the and or operators. So if, for example, with the and operator, you might write your if statement, if condition 1 and, if I can draw this and, condition 2. If both of those are true, so if condition 1 and condition 2 are true, then you're going to execute the if statement. So basically the idea of this is when you use the and operator, both conditions must be true. For the entire thing to evaluate to a true statement. So inside those conditional brackets. In order for the entire thing to evaluate as true, that means that both condition 1 and condition 2 must be true. Alright? The second sort of way that we can compare conditions are with an or operator. So what this is saying is that an example of this would be if condition 1 or, and that's what those double vertical lines mean, or condition 2 are true, then the entire thing. So basically what this is saying is that either condition 1 or condition 2 can be true for it to execute. If I condition 1 or condition 2 can be true for the entire thing, the entire statement in the if statement, or in the parentheses, to be true. Alright? Lastly, let me just talk about where we can find some of the things that we can use for the Arduino programs. So if you take out your computer and you go online, you search Arduino, you will get to the Arduino website, and they have sample codes on there, and it's good to try and check out those sample codes that they have on the website. You can you can copy and paste even the code. Copy and paste the code into your IDE that you should have on your computers, and hook that up to the Arduino. And they have a step-by-step kind of beginner's guide of how to set up your Arduino with the code that they have in order to execute. So they have sample codes for you to try and get to know the Arduino themselves, and how to kind of set up your circuit as well. If you do not have an Arduino, they have some Arduino simulators, and I'm sure if you, I know actually, if you search Arduino simulators online, a bunch of free simulators kind of show up, and you can download these programs, and or a lot of them are in browser as well, so you can simulators, if I can spell simulators correctly, and you can try out these circuits or code that you want to try and execute, and you can add certain devices or circuits or whatever you want to them. And so Arduino simulators, they're fantastic to try and get familiar with it, especially since a lot of us don't carry Arduinos in our back pocket all the time. Most of us carry our computers around. And lastly, just kind of, let's not to try and do new things. So when you start a new code and to try new stuff out, I think that's kind of the core of engineering and computer science. Let's try and test out new stuff, you know, to change the numbers around, and you really get to see how some of these functions work and how they operate. Computer programming and also engineering are one of those fields that it's kind of trial and error, and so you gain more knowledge by doing more and practicing and figuring things out on your own. And so if you put in the time, you'll eventually understand what's happening. And I think that's really important, to that discovery of these sort of devices and engineering and computer programming. So I would definitely behoove you to do this on your own. And thanks for watching. I hope you got a lot out of it.